Hello friends. In today's session we are going to see how do we represent non-perfect squares of positive real numbers on a number line. Now we'll talk about non-perfect square roots of positive real numbers. So till now we were talking about non-perfect square roots of integers. Now we'll talk about if we don't have an integer there, we have a real number which is a non-perfect square root and we need to represent that on the number line. So let's represent root x when we know that x is equal to 2.5. So how do we start with it? Let's start with the number line which is 0, 1, 2 and so on, and on the negative side also it is the same way. Now, so first of all, what we do is starting from 0, which we call O here, we draw a line segment on the negative side. We can do that on any side, but here we will be doing it on the negative side of length 2.5. Now, we're not saying that this is representing minus 2.5. We're just saying that we draw a line segment of length 2.5, which is OA. Now we extend this number line. So we have this line segment OA. Now we extend this line segment to the right side by 1. So this point is B now. So we have the point O here, A here and B here. So we get this point. Now we take the midpoint of this final line segment AB. So we take a point which is mid of this. So this will come to, so now this actually if you see this becomes 3.5. So we are saying 3.5 midway we take will be somewhere here. So we say midpoint of this we call it C. So we take the midpoint and now this midpoint as center and AC or CB as the radius, we draw this semicircle over here with C as center and AC or CB as the radius. We draw a semicircle. Now we draw a line which is perpendicular to point to AB from the point O. This point that we had which was 2.5, this AO was 2.5. So this point from AO, from the point O, we draw a perpendicular on the line segment AB. So we are saying this is this. Now this, we mark this point where this perpendicular intersects with the semicircle as D. So we are saying OD will represent root of 2.5. Now let's see how does it do that. Now we know that this point C, we can say CB in this case, we know that CB is equal to x plus 1 by 2, right? So we know CB is equal to x plus 1 by 2 because AB is x and we take the midpoint which is we extended by 1, so it becomes AB becomes x plus 1 and we divide it by 2 which becomes x minus 1 x plus 1 by 2. Now if we take CO, CO we know is CO is equal to x minus x plus 1 by 2. So we have CB so we know that CO is actually equal to AO minus AC. So AO in this case we know is x, that is what we started with, and AC is nothing but this is same as CB, which is the radius of the semicircle, and this is equal to x plus 1 by 2, which we've just found. So we are saying CO becomes equal to x minus x plus 1 by 2, which comes out to be x minus 1 by 2. So this is CO. So we know CO is equal to x minus 1 by 2. And another thing we know is that CD is also the radius of the semicircle. So this is equal to CB. So we are saying CD is also x plus 1 by 2. So now we can say BD is equal to CD square minus CO square. So we are again using the Pythagoras theorem and then square root of this. Now we know CD is x plus 1 by 2 whole square and CO is x minus 1 by 2 whole square and then square root of this. So this becomes 4x by 4 whole square root. So 4 cancels with 4. So BD becomes equal to square root of x. So this is what we needed to find out. So if BD, sorry, not BD, this is OD. OD is equal to CD square minus CO square. So OD becomes equal to root x. So now again with O as the center and OD as the radius, if we draw an arc, this is where it cuts on the number line. So we can say on the number line OE represents root x. So this is how the non-perfect square roots of any positive real number can also be represented on the number line. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.